TTL is a full-service engineering firm specializing in civil, geotechnical, environmental, construction materials testing, special inspections. We serve the energy sectors, construction, commercial, transportation, industrial, institutional, and government and municipal markets. Presenting today is Bo Cristwell. Bo has earned his degree from the University of Wyoming in civil engineering. He has 25 years of experience in the construction engineering on various commercial, industrial, government agencies, construction projects. Many projects include reviewing field data for compliance with the construction documents, quality control programs. He has served as a lead special inspector on numerous projects, managed teams of inspectors, and scheduled and coordinated inspections as required on project schedules of special inspections. He's responsible for reporting of special inspections to the owners, designers, and the building officials. We will have time after the presentation for questions, so please hold those questions until the end. The presentation will be posted on our website at ttlusa.com after this meeting. PDHs will be issued next week to all those who have attended. And without further ado, I present to you Bo Cristwell.
Hi guys, my name's Alan Cristwell. I don't know, Barry, is this showing up on my screen, this part right here?
Yes, it is.
I can just X that out, right? Yeah. Okay. So special inspections and design versus as-built conditions. So I'm going to talk about in this one, what are special inspections, and I'm also going to kind of talk about which ones are required in building code. And they're in chapter 17. We're going to slightly touch what's required in 17. And then I have examples of design versus as-built. And these examples are going to show things that we run into, and maybe not on an everyday basis, but things we encounter when we're out inspecting. So I'd like to start. One of the most common contributing factors to building failure in seismic and high wind events is construction that does not meet codes, standards, and design. So, you may have noticed at some point in your life, you're watching the news and there's been a hurricane somewhere, and maybe there's a, too big building, a Lowe's and a Home Depot, or something, just too big buildings, not those exactly. And you'll notice, the roof tore off of one, and it's not the other. And sometimes that can be a result of inspections or special inspections. So I just want to point out certain things like that. You can notice this stuff all around. The best way to assure buildings meet the proper codes and standards is to have increased inspection, specialized oversight during the construction process. That is a special inspection, okay? Special inspections also are spelled out in the building code, and I want to touch on that real quick. Because jurisdictional inspections and special inspections, there's a big difference. And just like I said, there's a big difference in those two. So I'll give you an example of a jurisdictional inspection. If you're not sure what a jurisdictional inspection is, a jurisdictional inspection is an inspection done by a building department or the building official. Okay. And so here is, this is out of chapter 1 in the building code. And, there's a lot of chapters involved in special inspections. So, so anyway, I want to do this. This is out of chapter 1. Required inspections. The building official, upon notification, shall make inspections set forth in sections 110.3.1 through 110.3.11. Those sections right there, they cover everything from slabs to framing to footings, insulation, just everything the building official needs. And special inspections is included in that. So the building official makes sure the building code is stating all these things in chapter 1 before it gets to chapter 17. So here's an example of a footing and a foundation of Chapter 110. This would be a jurisdictional inspection, okay? So footing and foundation inspection. Okay? The footing and foundation inspections shall be made after excavations for footings are complete. Any required reinforcing steel is in place. For concrete foundations, any required form shall be in place prior to inspection. Materials for the foundation shall be on the job, except where concrete is ready mixed in accordance with ASTM C94. The concrete needs not be on the job. Sometimes it's tough to look at certain things with the forms already on, walls, for example, but that's a jurisdictional inspection. A special inspection is spelled out. It's a little different, so it can be more detailed. For example, here's a chart, again, out of chapter 17, table 1705.3. These are required special inspections and tests, for concrete construction. So here's note 1, inspect the reinforcement and pre-stressing tendons if it's post-tension slab. Let's get a few of them. Inspect the anchors cast in the concrete. So that could be embed plates, that could be anchor bolts, that could be dowels, it could be a number of things. Verify the required design mix. Special inspector is supposed to do that. Inspect concrete and shotcrete placement, proper application techniques. So are they depositing the concrete correctly in the forms? Are they consolidating it? Are they free falling it? Is it going to segregate? Those things. There's a lot of things addressed, and it just goes on and on. So just to kind of point that out so you can see right away the difference in special inspection and a jurisdictional inspection. And that's just for concrete. So that was just one example. Now, special inspections are required in Chapter 17, as I stated earlier. The thing about these special inspection presentations, okay, there's some are very complicated, and they go through a lot of detail. And they go through so much detail, it's hard to understand everything about it. This particular presentation is a little simpler with examples, but to really understand special inspections, you need Chapter 1. Most people think it's just Chapter 17, and it is not. It is also Chapter 18, which is soils. It's Chapter 19, which is concrete. Chapter 21, which is masonry. 22, steel. Chapter 23, wood. So there's a lot of things. It's not just Chapter 17. But again, I just want to hit on the basics with you guys today. Special inspector team roles. So I want to talk about everybody's position on the job, and I may be leaving some people out, but I think I've got everyone in there. So I'd like to start with the owner. We're going to talk about the owner, his duties, the registered design professional, and a responsible charge. I may just call this registered design professional from here on out. Structural engineer of record. You'll see why his job is very important here also. Contractor, building official, testing agency, and special inspector. So the owner is responsible for employing and paying for the special inspectors to inspect the work identified as requiring special inspection. He can delegate the registered design professional and responsible charge to serve as the owner's agent and retain pay for the special inspector. And a lot of times this is the case. We may get hired through the architect. Occasionally, we may work for actually a structural engineering firm, but typically we work for the architect, which typically is the registered design professional and responsible charge. It doesn't have to be an architect, but it's typically an architect because he's the lead guy. So the registered design professional and responsible charge, his job is to inform the owner of the requirements for special inspection. Now, this is can be tricky because sometimes I've seen places, they'll leave it up to the architect to make this schedule of special inspections and require special inspections. And sometimes the building officials will say, well, there's no schedule of special inspections. So sometimes it's not up to the architect to decide if he wants them, but it is up to him to build a schedule of special inspections. Assist in establishing a budget for special inspection. Assist in retaining special inspection agents. Facilitate structural engineers' record involvement in the special inspection schedule. And we'll look later at the list. You see it's very structural. Not all of it, but a good portion of it. Respond to discrepancies noted by the special inspector where redesign is involved or design professional acceptance of work is required. That's be like your RFIs, and things of that nature. Also, as a special inspector, you may want to also make sure this guy right here, he's actually on the distribution list, because sometimes they get left off. I've had jobs in the past where I wrote up things before and I thought, man, I just can't believe they haven't said anything about it. And so I would look into it a little further and I would find out sometimes they're just not copied on the reports. Structural engineer of record. Prepare the statement of special inspections. Specify which areas of work require special inspections and what inspections and tests are to be performed. Review special inspections and testing reports. May serve as special inspector for some duties. Again, make sure these guys are on your distribution list, because if they're not, you can be late in reporting things, getting them to the right people. The contractor. Construct the project in accordance with the construction documents and control the quality of construction. Now, so everyone knows the contractor has quality control. But sometimes a special inspector may find himself getting involved in quality control versus quality assurance. So contractors hopefully will start they'll continue to look at their work before they call it out for the special inspection. But sometimes that just doesn't happen. Cooperate with special inspection and testing agents and familiarize themselves with the requirements of the program. That has been a difficult problem to solve with contractors a lot of times, because again, a lot of them don't understand the difference in the special inspection and the jurisdictional inspection. So there's been times I've been out on the jobs and they'll tell me like, hey, we don't need you. The building official came by, or the building inspector came by, and he signed off on the concrete, so we're good. We don't need you. Or somebody else came by and said, it's good. So you can tell them, well, that's not a special inspection. It's just it's an uphill battle. But the guys are getting better at it. Provide timely notification for special inspection and work with the inspector. They typically do that. They do the best they can with their tight schedules. Provide safe access for agents. Review special inspection for testing reports. And correct deficiencies identified. And this safe access, they do provide access. I'll give them that. They'll give you a lift, or they'll make sure you can get to your work. They do understand that part. Know that. Also, let me just back up. The contractor, sometimes you find yourself in a weird position, and you're doing inspections, but you're hired by the contractor. And it just is not a good idea. It's kind of a conflict of interest. You're really not a third-party inspector when you're working for the contractor. But sometimes that really happens. And sometimes you can get into a bad problem where the contractor will say, hey, you send me your reports, and I'll distribute those reports to where they need to go. And you're working for him, and that's the rule. And so you always get concerned in areas like that, in positions like that, because you just don't know if your word's getting out there, your inspections are getting out there. It's not a great idea, but it does happen sometimes. The building official. Require completed statement of special inspections prior to permit issue. Again, that right there sometimes may not be on the plans. It may actually be in the specifications. So this statement of special inspections, if it's in the specifications, when it goes through the plan review stage at the building official's office, sometimes they don't see it because they didn't review the specs all the way. And then another thing is, again, if they're required, some will say that's up to the registered design professional responsible charge to do the schedule of special inspections. If it's not in the plans, then they're not required. That's not the case. Like we said earlier, that's not the case for the registered design professional to decide if they want them or not. It's the registered design professional should do the schedule. So that's something the building officials typically will catch, but sometimes it falls through the cracks. Review special inspector qualifications and approve qualified inspectors. At TTL, we have ICC, International Code Council approved special inspectors for concrete, masonry, fireproofing, steel bolting, structural steel bolting, welding. We have American Welding Society. So we try to get all of our guys certified. As an engineer, I started out, I worked in the inspection field a long time ago, but actually, when I took the ICC courses, they're very good courses. Highly recommend them. Review interim reports, perform regular jurisdictional inspections at the job site. So there's your regular jurisdictional inspections. Require final report of special inspections prior to issuing the certificate of occupancy. So at the end of the job, the special inspector or his agency will write a letter stating which inspections were done and completed. All of team members, the building official is the only party with legal authority to enforce the special inspection provisions of the code. Testing technicians should test materials and not inspect work. That's another thing I'd like to kind of talk real quick on. A lot of times our technicians will be out, go out to maybe look at some concrete or test some concrete or something, and they'll get kind of drugged into something saying, hey, what do you think about this? How's this look? Or whatever. So we need to make sure our technicians know that they're not inspectors, they're there to test the truth. The special inspector manage the entire special inspections program. Establish and maintain appropriate communications with the owner, registered design professional responsible charge, structural engineer of record, contractor, testing agency, and the building official regarding the SI process. Maintain records of all tests and inspections related to statement of special inspections. Review and inspect testing reports and bring discrepancies to the attention of the contractor, registered design professional, and structural engineer of record. So there's those guys right there, the architect and structural engineer. We want to make sure those guys are always get a copy of the report. There's several types of jobs. When you think about it, in my book, there's three types of jobs, okay? There's a job that has discrepancies that are not closed. There's number two, there's a job that has discrepancies opened and closed. And then there's another type of job that has a lot of discrepancies. So the best job in my mind has always been number two, where it has discrepancies and they get closed. That's normal because you're building a large building and it's hard to build something of that magnitude without having some, I wouldn't say mistakes, but some things overlooked. So if you have a job with no discrepancies, that's probably not a real job. If you have a job with tons of discrepancies and they're not closed, that's probably not a great job. And then so when you have discrepancies that are open and closed, that's really kind of special inspections required. Okay, so this, I'm going to go through these. There's about 18 of them. And we do a lot of these inspections that we don't do. And so I like to start, and this is right out of chapter 17, the special cases. So a special case is basically, say, a shoring wall, for example. That would be a special case because the shoring wall is holding open an excavation that men are going to be inside working, people, men and women, will be inside working. And so if the bank or the soil sloughs off, it can life safety issue. The next thing is steel construction. That's your bolting and your welding, things of that nature. Concrete construction. I think we all know that. We talked about concrete construction a little earlier. 1705.4, masonry construction. Last month we did a thing on masonry. We'll talk a little bit about masonry later. Wood construction, soils. Wood construction actually shows up in several areas. It shows up here under wood construction, and it actually shows up again, and I'll point it out to you. Soils, a lot of people think, when you're testing soils, that's just not a special inspection, but it is. And we'll go over that. Driven deep foundations, that's anything like a drilled shaft, a helical pier, auger cast piles, drill displacement soil piles, things like that. Fabricated items. Fabricated items are shop inspections a lot of times. You can have them for wood trusses. You can have them for prefabricated cold form metal framed panels. You can have them for structural steel. You can have them for all types of things. The next thing is testing for special inspections for wind resistance. That is basically, that can be wood and that can be cold form. Special inspections for seismic resistance can be wood and it can be cold form. Testing for seismic resistance, we don't do that. Sprayed fire resistant materials, we do that. That's for intumescent and the cementitious sprayed materials, mastic and intumescent fire resistant coatings. Exterior insulation and finish system. You'll notice a lot of these are structural items, but when you get into the exterior insulation and finish system, it's not really a structural item, but what it is it's like a stucco, of course, on a building, and water can get behind there and it can grow a lot of mold. And then when that mold grows, it can be a life safety issue. Fire resistant penetrations and joints. This is brand new. This is not brand new. This came out in the code about 2012, and we're starting to see more and more of this. Testing of smoke control is something we do not do. We don't do testing for seismic, and we don't do that, but we pretty much do everything else on this list. So I want to go on and go into the next section. I'm not sure how we're doing on time, but the next section, I'm going to show a lot of photos of these things. It's examples of things that we encounter out on the project. So there's no questions right now. I'd like to proceed on and show you some examples of these. We just talked about these inspections. The first one is special cases. Of course, I told you that earlier. It could be like a shoring wall. So here's a shoring wall, for example. You see it's going around right here. Well, right here, right here, there's going to be a concrete wall placed, a footing and a concrete wall placed. So this concrete wall will be very tall. This is probably going to be a parking deck, garage under ground parking garage. So right here, so when you have workers between this shoring wall and this concrete wall, if this soil were to slough off, it could harm people. So, or if this building decided, this soil sloughed out right here and then this building fell over on it. But this is a special case, so it's not your traditional thing, but it is. It happens quite a bit. There's special cases. The building official can have special cases. It doesn't have to be the normal stuff. He can come up with all kinds of things that he feels require special inspections. Here is a building, a structural steel building, and right here in this area, there's an HSS shape coming in, a hollow stem shape coming here, and I want to show you guys. So I took this picture this is what the end result was, but I took this picture over time from the beginning to here to the end. And this was a job where the contractor actually convinced the owner that we did not need to show up unless we were called. So at that point in time, we got kind of in a position where we were being controlled. But this I want to show you guys. If you notice right here, this hollow stem check's coming in. And right here, you can kind of see something. And then earlier, in the year, that's what it actually looked like. Oh, you see that? That's actually a piece of rebar welded in there. It's actually a big no-no. There's a column. You see these anchor bolts, they're not quite on all the way. And then this is going to get a topping across it right here. Then there's going to be an insulation put in. Then there's going to be another topping. This is the next level you can see. So that never really got tightened up. And that never got a bolt at all. Hopefully these things were corrected. I believe they were. This was a column that was too short. So they just kind of built them a little, kickstand or ladder thing there, support. So that got written up. That did actually pass. So this is another one. The anchor bolts, of course, were stripped on this one. So they put a bunch of washers on it and got a little bit of thread on it. Of course, that one. This was again, this was in the masonry inspection. Common problems in masonry Zoom meeting we did a little earlier. So the mason has built this wall and he's left the job, and then the structural steel guy comes in. His embed plate is at the wrong elevation. The problem with it at the wrong elevation is this guy had to modify his work. So then, there's more trades modifying work, and then this had to be written up and get RFIs and everything. One thing about masonry, I kind of didn't mention earlier, is masonry. I'll just talk about it in masonry. But masonry can be overlooked because it's not a jurisdictional inspection. So if there's not a special inspection on your job, masonry doesn't get looked at, and it's the only trade that really doesn't get looked at. Here are some light gauge steel trusses. It required some lateral bracing right here. And every time I kept telling them they needed more, they kept putting more stuff on there. And finally, they got it. This again, this right here is a girder truss. Trusses typically require inspections if they're over 60 feet long. By the code. Now, but this one's unique because you'll see right here, this is the girder, and these are some trusses coming into them. If you look, they're not connected to the girder truss. As a matter of fact, they don't even touch the girder truss. They're in the air. So, another issue we ran across. Concrete. This is a slab, a podium slab right here. It requires ties on top of the podium slab. It requires ties on the bottom of the podium slab. And when we got out there, this is what was found. So the podium slab is going to go here where the ties are. And then up here will be the column again where there's no ties. So this is not that bad, but what can be done is they can move these ties down to here and add some more, or just move these ties up. There's no ties down here. So there's nothing that can be done there. Except actually check here. Here's a picture of a footing. You'll see here's a top mat of steel and the bottom mat of steel, and then here's some dowels, wall dowels. You see them coming up and down. And you can see this is 2 foot, 1 foot, 2 foot. Just basically this wall is in the middle of the footing, kind of how it's supposed to be. And when we went out and looked at it, it didn't look too bad, but I want to show you what it looks like from this end. See, it pretty much just runs off the footing almost. This is actually kind of a common problem. Because when they build a building, they kind of start the footing and it's kind of rusty and pretty close. And then they put the wall in and it's a little even tighter. And then maybe there's a pedestal with some anchor bolts, and then they get a little more control, but starting out, they can't start out bad. And sometimes this happens, and it happens quite often. It happens in masonry and it happens in concrete. This particular here, I wanted to show you guys this footing right here. Okay, it has anchor bolts. 6 on S.4. I don't know if you guys can see that. If you look at 6 on .4, you'll see here's our mat of steel. Here's our matted steel, and here's our anchor bolts. Okay, there's our anchor bolts, and this is what we got in the field. The anchor bolts were too long, or the footing was too shallow, and they went into the soil. And also, you'll probably notice this is not an approved chair. This is not wood 2x4s is not hitting. Wood is not allowed, and again, you can see the anchor bolts into the soil. Again, just another picture of it, a little different picture. Here is a pier I want to show you guys. And this kind of happens quite a bit too. So you have a pier here, and you have anchor bolts inside of the pier. Right? Well, they forgot to put anchor bolts in this one. And so sometimes, they can get away with drilling an epoxy, but in this case, they couldn't drill an epoxy. So they had to chisel it down. So when we went back to re-inspect, we noticed there was no ties. There's no ties on it. And the anchor bolts are kind of not in too good shape. So then they put ties on it, but then the anchor bolts, this one and this anchor bolt, is outside the ties. And of course, there's not enough ties. There's a little picture. You can see the anchor bolts just kind of up against there. It's really, there was a lot of problems. Here's another job. You see the dowels right here coming out with the ties around it. So if you notice, these anchor bolts are completely out of here. Out here in unreinforced concrete. What they've done is they actually they built this pier larger to accommodate to this because they thought that might be the answer, but it wasn't. Here's a step. So I wanted you to notice on this step, you can have a 8-inch minimum, 24-inch maximum, and this is the type of reinforcement you would use in that for a single step. And in a multiple step, you would have 8-inch steps, okay? So single step 24 or do multiples of 8. And so here was a project, they had a very large step in it. And I had told these guys to start vibrating this. And when they did, they started to blow out their forms. So they just quit. And I went back later to observe what was going on. And this is what was found. This is my tape measure. So that's a 57-inch step. The problem with the 57-inch step, there's a lot of problems. But another one, this is kind of a masonry thing too. You'll see there's 1, 2, 3, 4. That's a rip. 5, 6, 7, and a rip. So there's that's your maximum pour height right there. But what they'll do is this will be ignored typically a lot of times, and they'll put 7 or 8 courses back here in the back, and they'll pour that and just all of a sudden include this with it. That's something you really need to watch on your steps, especially if you get into some masonry. Utilities. So we step under utilities. This is a footing, you step it down under a utility, and there's several types of steps, but that's typically what a footing step is for, is to get under utilities. So this is a utility, it wasn't stepped under. This is just a pipe, it's not that bad. Here's another simple one, that would have been an easy one to step under, and they went back and fixed it. But sometimes you just can't fix everything, like this, for example. So sometimes, this was brought to the engineer of record because this is not really like some utilities. This is serious utilities. I mean, this is what I call, what do you do in a situation like this? Or this. First thing I did is call the engineer of record, but I just want to make sure they knew that it's got a little bit of utilities in there, maybe more than you thought. So here's a retaining wall, okay? So here's the concrete wall. See that right there? And here is the footing. See that right there? And so here's where the soil goes on the large part. Okay? Down here's some small, there's a little bit of fill, small amount of soil. maybe a sidewalk or something's going to be out here. And when I looked at this one, they actually read the cut backwards. They put the small side where all the field goes, and then put the large side where it's going to be relatively flat. These guys are pretty upset, but I had to redo the whole thing. These cantilever walls like this, it is, if you have a lot of those and you have guys that aren't really savvy with reading their plans, this happens, this does happen quite a bit. Not as often as some other things, but it does happen. The next thing I want to show you some examples of is masonry construction. In masonry construction, I want to show you again, we talked about this earlier. So here's a cut, 5 on 502. See, this is a block building. Those dashed lines under there, that's the footing, it's a W28, that's what that footing is. You look at that cut, 5. Here's your footing, here's your steel, here's your dowel. The dowel goes up the center of the concrete block. Okay. And then on top of that block, there's a slab, and there's the wall, and there's some brick out here, veneer. So it's on the outside of the block. But the dowel's in the middle. So when I look at this footing, and you'll see this line, this string right here is the center of the dowel. And again, this is one of these, it happens a lot. So, but can you imagine if the dowel was actually, if they actually poured this, placed this, the dowel came out right here, so half the block would be in the dirt, it wouldn't be well. You'd have some veneer over here, but your wall would be bearing mostly just on unreinforced concrete, not very much of it. So, like again, this happens a lot, and it's pretty easy to solve these issues because you can say, your footing is in the wrong location, and they'll say, well, no, footing's right. And you'll say, okay, and then your wall dowels are in the wrong location. They'll say, no, they're right. And then you can say, well, something's wrong, one of the two. And then they get scratching their head. Masonry, here's a masonry intersection. You can see the concrete block. 1, 2, 3, 4 pieces of reinforcement there. Here, there's 1, 2, 3. That's a corner. So you can basically think about this as a corner too. 1, 2, 3, or 1, 2, 3. Sometimes with this arrangement, you can't quite get 4, but I want to show you a few examples. So here's 1, missing the other 2. Here's 1 here, but the 2 are here are missing. They got them here. That's good. I hope they got them. They didn't just drop them in. Here they got none. The problem with masonry, you need to get on it early because right now to drill an epoxy into this footing, there's so many courses up here that you can't get a drill get hardly long enough to clean out the hole to put in reinforcement. Intersection got missed. Oh, problems. Here, this is a mezzanine I wanted to show you guys. Okay. There's a cut 4 on 4.2. It's right here. Right? I'm going to show you this. These are the joists. This is the mezzanine, which is like a deck in the building, like a half second story or something. And you can see the bar joists come in and they bear down on this bond beam. Okay? And then there's a strip, an angle here on the decking. It bolts into this bond beam, and that's what the slab pours onto. So this is basically like a double bond beam. And here's what we found when we were out there looking, that none of the bolts through the angle, none of these were in concrete or in grout. They were just all loose, and you can't see them down there, but they were loose on the whole job. And this is really a good reason why this is a cut through. They had an opening, so they're bolting here into air. So the whole thing they bolted into air, which didn't work, and you'll notice this embed plate's kind of low because it was supposed to be up here, and then the angle was supposed to be up here. So either the block's wrong or the mezzanine's wrong. It's one of the two. Here's a footing being placed with dowels coming down through here and coming down through here. Now, there's utility of the way. So what they did is it just formed it up and stopped, and they were going to lay block across it. Just lay the block right on across the utility and the dirt and whatever, and just keep it rolling. soil. Sorry, soil. Here's a footing as far as masonry. This rebar got kind of filled in from an excavator, so they've changed their design. That situation. Got some great little examples from wood that I'd like to show you guys. If you'll notice, these joists, rather large, 2x10s, I think, and they're in the roof system. And you'll notice right up in here, I don't know if you can see that, it's notched out. So that joist is maybe got an inch of wood right there, and the rest is just cut out. And this was they called for a final inspection. They actually fixed this though. Eventually they went back and they added hangers. Corrected this issue. These are micro lams or LVLs, laminated veneer lumber. You see there's 4 of them. This is a big beam. This is more like a girder. See, it's carrying all these joists coming in here. Now this doesn't connect to this red iron. This red iron, this is the motel. So this red iron is in here, the structural steel, to open up the area like for a lobby in the motel. This isn't a motel, so like for a lobby, things like that, the breakfast area or whatever. But this was being supported by this top plate and 1 2x4 up there. So that's a wood framing thing. Here's another great thing. It's like the studs, they weren't long enough. So they actually, they lengthened them kind of and gabbed on the side. Don't know what happened there exactly. Bad situation. Here's another cut wood again. These are shear walls. And then you have the truss comes in. The truss comes in. Truss comes in. Truss comes in. This is shear walls now. And then there's blocking in here. You see 2x4 blocking between each truss bottom. And then a 2x4 band at the top. Okay. So I want to show you. This is the shear wall. The 2x4 blocking is missing. And the top plate is a little tore up in the shear wall. So this is not bearing on a whole bunch right there. Not a whole bunch at all. It's kind of sticky. Soils is the next in our list. I don't have a lot of photos of soils, but I do have. So I included what was out of the building code, and I just wanted to show you what's actually required for special inspections on soils. Verify materials below shallow foundations are adequate to achieve the design bearing capacity. Verify excavations are extended to proper depth and have reached proper material. To periodic inspections. Continuous and periodic, I don't know if I touched on that. Continuous is an inspection that you have to be present for during the whole placement of the material for soils, for example. Here's a continuous one. Verify use of proper materials, densities, and lift thicknesses during placement. And compaction. So you can't leave the job and come back and see that maybe 4 feet down, the soil was put in at the proper lift and compacted. Now, periodic is something you could come back and look, but you would look at the whole thing. You could still see it. Like if they were doing excavations, you could come back. You wouldn't have to watch them dig the whole thing, but after they finished excavating the whole thing, you could come back and check the whole thing. But you wouldn't have to be there the whole time. So you have to periodically come by and make sure, but you still would look at it all. Prior to placement of compacted fill, inspect, subgrade, and verify that the site has been prepared properly. So that's out of that's a special inspection for soils. Driven deep foundations. This is typically this happens. The mistakes in this, there's not a lot of mistakes. It's pretty much in location, or maybe the depth of the elements. That's where you get into this situation, mistakes and discrepancies. But you can see, again, I wanted to show you guys, this is for a driven deep foundation. This is for a cast in place deep foundation element. So this might be like a drill shaft or something. So you would inspect the drilling operations and maintain complete accurate records for each element. Continuous. Verify placement, location, plumbness. Confirm element diameters, fill diameters if applicable. Lengths, embedment into bedrock, adequate in-bearing strata, capacity to record concrete or grout volumes. And then for concrete elements, perform tests and additional special inspections in accordance with section 17.53. I'm not going to read this one to you, but you can see, this is not a jurisdictional inspection. So if you have deep foundation elements, you may want some special inspections on there. I would definitely want them if it was my building. Special inspections for wind resistant and special inspections for seismic resistant. As I mentioned earlier, this covers wood and it covers cold form metal framing. So I want to show you guys this. Here is a cold form metal wall. You can see the whole thing, but this is an X brace coming in. X brace coming in. There's a lot of these self-drilling screws in here, and they're down this side across the bottom. And if here's a bracket, it's at the end. There's a hold down right here. You see this little triangle. There's a bolt in it. That is actually right here. This is AA. This is AA. So right here, you see all these screws go in here and this large bolt, right? And here's what we got. So we got the large bolt. We got all the screws coming in. Yeah, I think they're probably in the 14s. You can see the plates for the bracing. The gusset plate comes in, the cross bracing in, the last stud screw, go around to the other side. You realize all through the hole. Well, guess what? This thing probably has half the capacity and it has half the screws. So that's another thing we talked. Here's another thing I like to show you. So typically, this is a structural steel building and it has cold form metal framing, which is pretty common. And you'll notice it's not connected. Typically, this would have probably clips coming off the web of the steel beam and coming over and holding these studs individually. But in this case, the contractor decided to screw this straight to the tails of the trusses. And the reason I found this, I wasn't there to do this work, but I was there to do a truss inspection. And doing the truss inspection, I knew that the trusses may not have been designed to carry this wall length with their tails. So that was kind of strange. So here it is again. See, they just connected it, So here's you got a stud here. It's got two screws in it. Stud here, it's got two screws, one each side. Stud here, screw each side. Stud here. So you got all these screws, but then you got one screw here. So you got two screws. One, two, 4, 5, 6. Those can be issues. So here's what I'm talking about with a structural steel beam and both form metal framing going across right by it up to the top. But these are not correct clips, okay? They should have a clip that slides up and down, and you should never cut through a punch out. But I'll show you that. So here's the proper clips. And so you're supposed to put the screws in the clip kind of like that. So when the building expands and contracts, it can move up and down. And again, just because they had them, they still just use them. And here's where they would put one in the bottom and one in the top, so it couldn't expand and contract. I'm not sure what that was all about. But again, bottom and top, they just didn't. I don't know. Just a bad mistake. Here's a joist, cold form metal framing joist. Cut through the punch out. You can't cut through a punch out. The punch out needs to be from the center to the edge of the stud, at least 12 inches. This is the bottom track of some cold form metal framing. Typically, it'll state in the plans that the bottom track should bear on solid material 2,500 psi concrete or something like that. So in this case, you can see it's actually not bearing on anything hardly. And you can see from this angle, it's really bad. This is a big facade, like a big box store. Here's a header. It didn't make it all the way. They put another piece in, and this way off. I don't know. So this is definitely a fail. This is the bottom track of a cold form wall. And right here, you'll see their studs just weren't long enough, so they bumped this up. So they bumped it up with a piece of interior gypsum board. Now, all right, so we can get into the questions. I can go further. I haven't heard anything from anybody. I hope y'all are still out there. So we can take questions. And if not, I have a good 30, 40 more slides of great examples. So we can do whatever you guys would like. Hello?
Thank you, Bo. I appreciate that. To the group, if you guys will unmute yourself, and then you can ask a question that you may have. And that's the format we'll use. Thanks a lot.
Bo, I have a question. Can you hear me?
Yes.
You're showing a lot of deficiencies.
Yes.
And I'm assuming most of those got addressed in a report and were worked out with the contractor. But how do you prevent that rework? What's the best process to minimize or eliminate rework?
You know, the best process that I've found is to train your special inspectors to realize, to make them realize that they're actually a part of the job and they're there to help the job. They're not there just to go do an inspection and write a report and get a paycheck. They're a part of the job and they need to contribute to the job. So they need to have a little bit of self-motivation and not just wait to be called for everything. You know, make it a part of their routine and get in there early and get a hold of the correct people as early as you can and get it straightened out and not wait to the very last minute. You know, so if you're running late, you know, maybe you should look at, you got 300, 400, 500 feet of footing. Don't wait till an hour before the concrete pour. Get out there early. Get out there maybe a day or two. The contractor is probably working on something for a week. It's not, he doesn't just perform this work overnight, And so it doesn't take a lot of time, but increased inspection, special inspections, I think is the only way to get around this stuff. And that's a great question. And I know there was a lot of gloom and doom in that presentation, but, there really is a lot of situations like that show up. Did that answer your question, or you think?
Yes, thank you.
Okay.
Next question.
Anyone? I'll tell you this, and I probably said this earlier, I'm not 100% sure. This presentation, we've done other presentations in the past that are more complicated, and it's almost like it's too much information to take in at one time, because this subject is so broad that 50 minutes you just can't cover everything. And I kind of jumped around, but I tried to keep this one simple and then show you some examples to try to make the connection. Yes. Barry, I thought I heard someone there for a second. Do you know?
Yeah, I did too.
Okay.
Please go ahead and ask your question. Well, if there's no other questions, we will, Bo's contact information will be on the slide that we post. So if you have any questions on his presentation, please feel free to give him a call or email. We'll be glad to answer any and all of your questions. And we do appreciate your time and attendance today. Otherwise, you guys have a great rest of the week, and we will talk to you next time. Thank you.
See you guys.